With this in mind, we can start to look at a actual Markov chain example. Let's take one that's a little bit concrete and close to our hearts, one of how a student might study for a class that might have only 3 sessions. Okay, maybe a morning session, an afternoon, and a night session, at which the end of the day, we might actually pass the course and receive the chance to get to sleep and pass the course. So, during the first session, we might say, okay, well, things are just getting started off. I don't mind concentrating, but there's a chance that I might just open my laptop and start filling with social media. So I might go to Instagram and browse here for a couple times, and after looking through a couple of different stories, return back to class. Okay, so that's a possibility. Or instead, we might just actually, instead of doing that, or after we return to that, we could proceed into the afternoon session. During the afternoon session, let's say there's some probability that you fall asleep. So maybe you don't get to pass the rest of the course. But if you're earnest and you stay on target, you may get to the evening class. And the evening class is the last session. And then during the last session, before the final exam, you might say, okay, I'm doing pretty good. I'm going to stop and go clubbing for a little while before finishing up. And then maybe at the club, there's some likelihood that the music is so loud, you forget everything and you have to return back to the class to relearn the material through video lectures, etc. Or that you might actually regress. You might have to go back and revise even class one or two. So after all of this, let's say you get to class session 3, you might actually take the final exam and pass. Maybe the pass is a certainty, and then you'd be able to get to the terminal state. So we'll say this is a terminal state. And we might denote that with a special symbol. Sometimes we use, like, say, a double circle, okay? And then we'll say once we get to a terminal state, we've finished the process, okay? We can also view this as a state that has an infinite loop, right? With probability 1, we come back and visit the state again and again and again. Okay. So with this in mind, what we can do is we can use this Markov chain and sample episodes from it. What do we mean by sample? It means just run through the Markov chain, this process, by sampling, right? So we might start off in the first case, so something like this, which says, let's go right through the state space and finish off with sleeping, right? So I go through session 1, then class session 2, number 3, take the final exam and pass, and then, okay, I finished everything, good job myself, and I go to sleep, okay? But I also might do other things here, right? So I might say, okay, maybe this is a possible way that I could sample this. This says I go to class session 1, but, I get bored. I go to Instagram, maybe do that once or twice, okay, and then come back to class 1, go to class 2, and unfortunately, I'm feeling pretty exhausted after that, and I fall asleep. Okay, so both of these are possible trajectories. We could also do something like this, which is go through the first 3 steps, end up going to the pub, regressing, going back to class 3, then finally taking the final exam and passing through, and then going to sleep. Okay, and the important thing to note here is that samples will eventually end, because we are going to terminate again at our terminal state here. And then that just means that once we run the sampling process long enough time, at some point or another, we're going to reach a terminal state, and that signifies the end of the process, okay? So even though there are loops that are going back and forth like this one here or this one here, at some point in time, we're going to go through the sampling process of using these probabilities here, and we're going to still end up with sleep. So it's an important thing to know that episodes are always finite. Even though there might be some self-loops or cycles in our graph. And so what we can do is compose all of this into a probability transition matrix. This is RP that we talked about earlier. Again, our indices are from the source, which we're going to say is from here. okay, to the destination, which we're going to say is the 2 here. Okay, so these are the 2 on the columns, and the source are the rows, right? That's why we said we're going to normalize each row here, sum them equals 1. Okay, and so you can see that it holds out here. So you can see that from C1, I have a 50% chance of going to Instagram, or maybe I actually go directly to class 2, and these will sum to probability 1. Right, so you can see all of these different cases here. For example, when we're at the club, we can say that there's a 20% chance of going back to class 1, 20% going back to 40%, sorry, of going to class 2, and another 40% of going to class 3. Okay, so all of these different rows have to sum up to 1.